Today we're going to do Chapter 5 Toolbox, which is kind of, if you remember, we've done a couple of those. The information you need for that chapter to be able to understand it. And today is properties of exponents. So we're going to be looking at properties of exponents today. These are some ACT questions, just random, get your brain back this morning. On the first one, what did y'all do? C. Okay, how'd you get there? I think it's A. So A or C. What do we do? Okay, first, negative 8 times 7, which is negative 56, so that pretty much gives us A, B, C, or D, could have been any of those. And then you multiply the x cubed times the x to the 6th. Does anyone remember how you multiply two things with the same base? You add the exponents. So 6 plus 3 does give you 9. So that means we're either this one or this one. Negative times a negative gives you a positive, so A is the correct answer. Because one of the things we're going to learn today is the adding exponents. So we're looking at the exponent on that. For A on 24. Is it 24x? See? The 3 plus the 5. Solving inequality, we've done that in this class. The easiest way is to distribute and do it by hand. You could use the calculator, but I think it would take longer in the calculator. If it were me, I would leave the x on the left, just because all the answers have x on the left. It's not, most of you could figure it out. If you put it on the right, it wouldn't matter. But just for making our brains think less, I'm just going to leave the x on the left. Even if you did mess something up at this point, because there's only 147 up there. But dividing by -1, what do you have to do when you divide by negative inequalities? And so that's why I said it might be nice to leave the x on the left so you don't have to think about that part. Good reminders. For two consecutive integers, the result of adding the smaller integer and triple the larger integer is 79. What are the two integers? There's an algebraic way to set this up. Of course, you could just plug them in your calculator. The smaller number plus 3 times the bigger one. So 18 plus 3 times 19. 19 plus 3 times 20. Right? You can add those up. Is that it? 19 and 20? So, probably for ACT, that's the fastest way to do it. If this weren't multiple choice, you would have to set up a word problem. So, B. Any questions about those ACT problems? Okay, properties of exponents. So, the first one, the one that you might have gotten wrong, that we haven't learned yet, this should answer how to do that. When you have two things multiplied together with the same base, a to the m times a to the n. That's the same as a to the m plus n. We add the exponents. Why is that? Well, if I have a squared times a cubed, isn't that a times a times a times a times a? And how many a's are there? 5 of them. Do you see why you add? See why that works that way? Okay, a to the n raised to the m. So say I have a squared cubed. What does that mean? That means a squared times a squared times a squared, right? So what you end up doing, if you were to add, you would get 6, but a quick way to get there is to multiply the two exponents. So we have an exponent raised to another exponent, you multiply. So a to the n raised to the m is a to the n times n. Am I going too fast? Okay. A to the m over, or a over b all to the m, that exponent goes with both. So an exponent distributes over division. An exponent also distributes over multiplication. What is not the case, and write this at the bottom, exponents do not distribute over addition. Star that in your notes. One of the most common mistakes in math is to take that distributive property that happens with exponents in multiplication and division and translate that into addition and subtraction. How many of you have ever seen x plus 3 squared and called it x squared plus 9 and gotten it wrong? How many of you have done that before? I graded those papers out. Have you had x plus 3 in parentheses squared? You've accidentally done x squared plus 9. What do you really have to do when you see x plus 3 squared? You have to do x plus 3 times x plus 3 and FOIL. You know what I'm talking about. So be careful about that. Exponents don't distribute over a plus or a minus. If you have division, a to the m divided by a to the m, you subtract exponents. The opposite of multiplication. The nth root of x to m, which I think we've talked about this one before, haven't we? When we had a 1/4 power, that meant it was a 4th root. And so we've seen that a little bit in this class. So the nth root of x to the m is the same as x to the m over n power. Anything to the first power is itself. Anything to a negative exponent is a reciprocal. And then the nth root of x is the same as x to the 1/4. So just some properties of exponents. That's what we're going to be working with today. Simplify and express using positive exponents only. Do some examples. Did anyone else need tape for your notebook? I still have a set of note cards back there. Bailey, that's that yellow thing sticking out. This is that. It's fine. Okay. The top one. Jacob. Jacob's is this paper one. Okay. And then James. Is that all that's left? Check in your backpack. Maybe put it like this. If not, we can get you all the stuff. I keep going. Add them to it. But what we're going for is the week before the final that you can dig that out and study. And the final will go back to August information. That's why I had you all do that semester. It's going to be midway, so you can stop thinking about. I would keep that semester review. If you are cleaning out your notebooks, I would keep the semester review. That would be a good W to the negative 8 divided by W to the negative 3rd. How would we do that? different orders, and they're all correct. And that's what sometimes gets people tripped up on these, is there's not one right process. But remember, we're always going to follow a rule. So, any ideas on something I can do first on the next one to the right? Not times. Okay, the negative 2 is an exponent. Would we agree? And so we can put it with everything at the bottom. Right? So we can put the negative 2 with everything inside the parentheses. So that would be negative 5 to the negative 2 over 2 to the negative 2. What would the x be raised to? Follow a rule. What'd you say, Kyle? Negative 6y, negative 6. I have a power raised to another power, right? So I'm raising a power to a power, and so the rule there is that I multiply. So that would be x to the negative 6. Okay, so far so good. The negative 6. So x cubed raised to the negative 2. So power to a power. Okay. No. Definitely not simplified. There's a couple of things that I would want to do. First of all, how many of you, your brains get a little hurt by negative exponents? Yeah, can't I switch them around and make them positive from that last property we looked at? So I'm going to go ahead and do that. I'm going to make it 2 squared on top, x to the 6th on top, and negative 5 squared on bottom. Now, something I have done that I figure most of you would have messed up is I kept a parenthesis on the negative 5. Someone tell me why I did that. Did the 2 go with the negative? Did they go with everything? The negative 2 went with everything, right? So if I left the negative out, I would have been forgetting it. I did to make sure I grouped that in. Be careful about that if you have a negative number. And someone said, I think it was Kyle, negative 5 squared. What is negative 5 squared? 25. Is that the same as if the negative's outside the parentheses? It would tell you negative 25, right? So just be careful about that. The exponent goes with everything in the parentheses. And so that includes the negative. So just to make sure I didn't forget that, I put parentheses around that negative 5. You could put parentheses around the 2 also. I just didn't need it. Didn't have a negative with it. So that one was a little tougher. We've learned some things, though. We can do things in whatever order our brain prefers. If switching things around to make exponents positive is what your brain likes to do, you may want to do that every time. We could have done that on the W's at the beginning. Couldn't we have made that W cubed divided by W create? Couldn't we have switched it? And then 3 minus 8 would be negative 5. We landed at the same spot. So we've learned we've got some options. Okay, let's look at the next one. What would you do first? What? Simplify what? Okay, the 8 and the 6. How many of you would have done that first? Just James. Is that okay? That's, yeah. So I like that idea. You would have had to do it there. But the first thing he saw was, hey, those numbers simplify. So he took care of it. He's going to be. Noah. Okay, switch the positive and negative exponents around. Does that work? Do we have to do it that way? We could just go ahead and subtract exponents. So either way works. I am pretty flexible. So I've got 4x, and the x to the negative 2, I'm going to move to the top and make it positive. And then 3y cubed, and I'm going to move the y to the negative 2 to the bottom. See this x to the negative 2? He said switch all the negative exponents out. I took this one and put it up there, and this one and put it down. Because that's what he told me.
Oh, yeah.
I probably wouldn't have done it that way. I probably would have just gone ahead and subtracted exponents. I would have called this x to the first and then 1 minus negative 2. What is 1 minus negative 2? Positive 3? Well, look, what do I get when I finish this problem? Don't I get positive 3? What exponent is here? Nothing's really written there. It's a 1. So 1 plus 2 is 3. 3 plus 2 is 5. You would have landed there either way. So, good thing and bad thing, you have a lot of options. Sometimes that's a bad thing. So what I would have done is I would have gone straight from here. And see that 1 there? I would have done 1 minus negative 2 and gotten x cubed. And then I would have done negative 2 minus 3. I would have gotten y to the negative 5th. And then you would have had to move that y to the 5th. And again, nobody's there. If you're thinking, you have options. Okay, let's look at the bottom left. Have y'all seen these on the ACT? I know for you seniors, I'm sorry. You juniors. On ACT. We have 2 juniors in here. Okay, what about the next one? Okay, good. I would put the exponent with everything. Now, I am going to write this out because later you won't do this. This is too much work. You'll do all this in your head later. But I'm going to show all my steps. I'm going to put the negative 3 with everything. That does include the 3. It is a separate number that's in the x and the y. And what I mean by you'll do this in your head is at some point you'll just go ahead and multiply those in your head. You won't show this step. Now I'm going to show it. So I put the negative 3. I'm going to go ahead and do the multiplication. Power raised to a power I multiply. So negative 2 to the negative 3 gives me x to the 6th. So let's define the rule. That one's this one, right? Which is multiplication. This one is where you add. You have x to the power times x to the power. But when you have a power raised to the power. So keep that note card handy while you're working your homework. So you can go, okay, what am I doing with this? Any questions so far? 3 to the negative 3rd power is probably something you don't know how to do in your head at this point. So let's go ahead and get rid of that negative exponent before I try to cube 3. So this would be x to the stays on top, but the 3 cubed and the y to the 6 go to the bottom. And now I can do that in my head. What is 3 cubed? More times. Okay, 27. If you type 3 to the negative third in your calculator, it would give you a decimal that's equivalent to 127. This one is all numbers. Let's see how it plays out. Yeah. You sure? Okay. 10 to the negative third, 10 to the negative 4 thirds, 10 to the negative 11th, 10 to the negative second. Oh my goodness, there's a lot of things. The first thing I notice is all 4 of them have the same base. So I can add and subtract. Now some of you would want to get this, the same thing on top and the same thing, or flip them so you have all positives. I probably wouldn't because I feel like that's an extra step. Would it be wrong if you flip them all? No. So it's totally up to you. Makes no difference. You can do this. We can figure out how many ways, a lot of different ways. Probably what I would do is combine the top 2 and then combine the bottom 2 first. And then do 1 subtraction. Is that the only way to do it? Absolutely not. You can do whatever you want. There's a lot of options. So I'm going to add negative 3 plus negative 4 thirds. Completely by hand, that's a problem where you have to get common denominators. Do you ever have to do things completely by hand? So in your calculator, type negative 3 plus negative 4 thirds. Say it again. Negative 13 over 3. And on the bottom, I get 10 to the negative 13. Added the exponent. Any questions? So on the top, I did negative 3 plus negative 4 thirds. And on the bottom, I did negative 11 plus negative 2. Okay, so I'm going to now subtract these two, right? Negative 13 thirds minus 13 minus negative 13. If you watch the video and you're okay with that, then you can. Negative 13 thirds minus negative 13, which is like plus 13. Which is? No. Follow a rule. Follow a rule. 10 to the first divided by 10 to the first is 1. Because 1 minus 1 is 0. But don't make up a rule. What is this? Do it. Negative 13 thirds minus negative 13 or plus 13.
You don't split.
You can. Do what? 10 to the 26 over 3. Is that what we got? So we learned something. Is that the same as 1? No. So we can't just cancel things. Now, when can we cancel things? Well, if they're the same exponent, then of course we can cancel. But the property is subtraction. Let's talk about y really quick. Say if I had 10 squared over one of them, right? But wouldn't it be faster to subtract those exponents? Yes, it is first. So yes, canceling is something that exists. Just be careful with how you apply that. You can only cancel something that has the exact same exponent. Good question. This is a perfectly good answer based on the directions. However, another perfectly good answer would be the cube root of 10 to the 26th. So if you wanted to write it that way, you could. Either way. The next slide will make us write it that way. This one, it just said positive exponents, so we would have had to accept either. This slide says, find the value without using a calculator using properties of exponents. So that's where we're going to have to know what a 1/2 power means. No, I'm not about to take your calculator away. Yes, you do need to know how this works. So it's for that purpose. Okay. I don't know. We'll have to find a property, won't we? First of all, before we talk about the exponent, I want to talk about negative 49 to the 1/2 and parentheses negative 49 to the 1/2. How are those two things different? The two left-hand questions. How are those different? Okay, the 1/2 power goes with the negative on the bottom, right? And the 1/2 power does not go with the negative on the top one. Does everyone agree with that? So look back at your note card. What does a 1/2 power mean? It's square rooted. So this means negative square root of 49. Right? Which is negative 7. What does this one mean?
Is there a negative in it?
Square root of negative 49, which means the answer is either I, 7i, or you could say not real. Either way, I would take both. Now, would your calculator give you that same answer? Yes. Okay. So it would tell you it's not real. And the top one, wouldn't it tell you it's negative 7? You type that exact thing in your calculator. You need to know what the powers mean for when it's not numbers, for when it's x's and y's. It's a skill. We've always struggled with negative exponents, right? So what should we do with it? Get rid of the negative, make it over 1. I want to rewrite the 9 to the 3 over 2 using a radical. So which one, looking at your note card, which one is the root and which one's the power? Good, the bottom one's always the root, the top one's always the power. So this is the square root of 9 cubed. Now you can apply those in either order. It doesn't matter what order. If I truly had to do this without a calculator, don't I know the square root of 9? What's the square root of 9? 3. And what's 3 cubed? Can I do that? So this is 127. Would you agree that looked almost impossible to do by hand at first glance? But then following the properties, it's not too terrible, right? We just got to follow the rules. 16 to the 3 halves, how could I rewrite that? Square root of 16 cubed. Again, I can apply those in either order. I can do the square root first or the cube first. So, what's the square root of 16? 4. 16 times 4. You might have to write that down if it's 16.
Okay, so it makes it 30.
Then that would be a cube root squared. So
So 4, 5,
it's not horrible. One more thing, just because it's basically coming up with properties of exponents, scientific notation. When your calculator does scientific notation, it writes 3e negative 5. So we'll have to keep that in mind. Calculator writes it slightly different than we do. Scientific notation is multiplying by a power of 10. And so comes up in science class every now and again. I'll pop up in math class. So in scientific notation, we always have a one-digit number. So 8.3 times. So 10 to the what? 1, 2, 3, 4, 5, 6, 7. I moved the decimal 7 places. Times 10 to the 7. How do I know it's a positive 7 and not a negative 7? Right. It's a big number. Wouldn't a negative exponent be dividing by 10? Because it would flip it. See how it works? So a positive exponent would make a big number, a negative exponent would make a decimal number. So this one we're moving a decimal 1, 3, 4, 5, 6, 7, 8. But this time it is a negative 8 because I'm dividing by 10 to the 8. Right in standard notation. Well, this is 3.0 as of now. 10 to the negative 5th.
we just
Well, not for standard notation. Standard notation would be like this. 1, 2, 3, 4, 5. So that's one there. Why did I move that way? Why did I move to the left? It's a negative decimal, or it's a negative exponent, which means I'm going to be dividing, so I need a decimal number. So I'm going to move to the left. This one, I'm going to move to the right. 1, 2, 3. So 7,320. So now you can work with your calculator if it gives you an answer in scientific notation. It is the toolbox. I hope it's the toolbox. Sorry, that